So, we're looking at trying to model the learning rule for a single neuron. So let's set up our inputs, x0, x1, x2, x1, x0, sorry, is always 1. And then, let's do it that way. So there's our inputs. We need some weights. So the bias, weight 1, weight 2. I'm just going to put some values in to start with. We're going to have the weighted sum. So, usual rule, weight times its input, weight times its input, and then weight times the input. Okay. And then we have our output from our neuron, which is going to be if the weighted sum is less than or equal to 0, we're going to put a 1 out. If it isn't, it's going to be a 0. All right. So that's where we are with just doing a single neuron and using the single neuron. What we now need to do is getting this to learn. So what we're going to add in here is the change to weight 0, the change to weight 1, and the change to weight 2. Okay? These are the things that we're going to add to our current weight to improve, hopefully, the weight. So we're getting the system to learn by what it's been exposed to. To do that, we need to know what our desired output is. So let's say we're going to do an OR gate. But it could equally be an AND. It could be anything that's linearly separable. Okay, so that's where we are with this. So the next stage is we actually need to calculate what that weight should be. That change to that weight, I should say. So we're going to have this learning coefficient. It's just going to be it's just a fixed value. I'm going to choose, for the moment, 0.5. So now we just use that delta rule that says the learning coefficient times the input for that weight times the difference between what we wanted and what we got. Gives us our change that we're going to make to weight 0. And we can carry on with that idea. Oops. Our learning coefficient times the particular input that that weight's attached to, so in this case x1, times the difference between what we wanted and what we got. And the reason it's 0 is because input x1 in this case is 0. We can do the same for W2. Whoops. So it's going to be N2 times the input that's on that weight times the difference between what we wanted and what we got. Okay. So now we've got the changes that we're going to make to our weights. So what we now do is we say, I'm going to take my old weight value and add the change. So old W1 plus the change to W1 the old W2 weight plus the change to that. We then use those new weights to give us our output and what we want and what we got. And then we just do a very mechanical thing of we just repeat that exercise. So all I've done is cut and paste the previous one, but it's now going to use, if we take this one, it's going to use the learning coefficient times the particular input times the difference between what we wanted and what we got. And we just keep repeating this. So all I need to do now is, is not do that. Is correct my mistakes. So it's going to be C3 times that. I can now just drag and drop this. Actually, I can't do that. I can drag those actions and I can drag those actions. Okay. So that's the first iteration of this. We've gone through every input combination and now we need to excuse me, try those inputs again and see what happens. So it's going to be the same sets of inputs. That's not going to change. The way that we do the net, the output from the neuron and what our desired output, that's not going to change. Okay. How we do this bit, that's not going to change. And how we do this bit, that's not going to change either. The results will, but the actual mechanism doesn't change. So what we now can do is, we've done this twice, do it 3 times, 4 times, 5 times, 6 times, until this happens. What you notice here, I hope, is that all the changes, to the weights are zeroed for that input combination, yeah, with these weights, which meant the weights didn't change. It's the same set of weights. We found our weights to make this happen. The system has learned to find those weights. And that's all there is to this. So we don't have to do anything else apart from set the system up, say I want these inputs, this desired output, make it happen. Okay? It's just a very, very mechanical process.